All right, so here's the equation in part D. Right, we have to solve the square root of the quantity 5 minus x minus 1, okay, so the minus 1 is outside of the square root, equals x. We're going to follow the same steps, right, and see where they lead us. The first thing that needs to be done always when solving radical equations is to isolate the radical. So in this case, that means I have to get rid of this minus 1 so that the square root is all by itself. So I put plus 1, which gives me the square root of 5 minus x equals the quantity x plus 1. Unfortunately, I can't simplify x plus 1. They're not like terms. I can't add them together or really write this any other way, which means I just have to deal with it. Okay. Step 2 says to get rid of your nth root by raising both sides to the nth power. So since I have a square root, I'm going to square both sides to get rid of it. So I square both sides. Right? On the left side, it's pretty obvious what happens. The square root and the square undo each other and leave you with exactly what was underneath, 5 minus x. On the right side, you have to be very, very, very careful here. We have a binomial x plus 1 being squared. Okay? In order to square a binomial, you have to write it out in FOIL. Okay? So in order to actually expand this out, you have to write this as x plus 1 times x plus 1 and FOIL it out. You cannot just put the square to both quantities in here. That's not how your exponent rules work. When you have a plus, you're going to have to write it out in FOIL. Okay, so x plus 1 times x plus 1 FOILs out to x squared plus x plus 1. Right? X times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1. So altogether, when we put this back into our equation here, we're going to be left with x squared plus 2x's plus 1. Okay, so this is the new equation we have to solve. So whenever you have a plus or a minus and you're squaring, you have to FOIL it out. Now back to our equation. This is a quadratic equation because it has an x squared. To solve quadratic equations, you get one side to 0. Okay, so let me go ahead and write out our third step, which is to solve this resulting equation. So like I said, to solve this quadratic equation, we want to get one side to 0. So that means I had to move over my 5, move over my x. So I end up with 0 equals x squared plus 3x's minus 4. Now this guy, we can either factor or use the quadratic formula. Or I suppose use completing the square if you really wanted. Okay, whatever you're most comfortable with. I would highly suggest factoring at this point, okay, because x squared plus 3x minus 4 factors super easily. Okay, so let's try to factor this to finish solving. All right, so we have a 1 out in front of the x squared, and we have a 4 on the end. So when we factor this trinomial, we build our boxes using 1 times 1 here, and either 1 times 4 or 2 times 2. Turns out that 1 and 4 are the factors that work. Here's the box if you need to see it. Okay, so in the end, this factors out to 0 equals 1x minus 1 times x plus 4. And then the zero product principle tells me if I have a product equal to 0, I can set each factor to 0. So I get either 0 equals x minus 1 or 0 equals x plus 4. Which gives me my two solutions, two possible solutions. X equals 1, right, when I isolate in the first equation, or x equals negative 4 when I isolate in the second equation. Now the question becomes, do both of these work? Okay, we really do have to check here to make sure that both of these proposed solutions satisfy the original equation. So here's our final step. Step 4, we have to check our proposed solutions. Okay, after solving our quadratic, we got x equals 1 or x equals negative 4 as our proposed solutions. When we plug x equals 1 back into the original equation, we get 5 minus 1 underneath the square root, 5 minus 1, minus 1 outside the square root is supposed to equal x, so it's supposed to equal 1. We simplify what we can. 5 minus 1 is 4, square root of 4 is 2. Does 2 minus 1 equal 1? Yes. So that tells us that x equals 1 is a valid solution to our original equation. So let's box it. Now we have to go on and check x equals negative 4. This is a little trickier because you have a double negative situation, right? When you plug negative 4 into the original equation, you're going to get 5 minus negative 4. Minus 1 equals negative 4. And simplify what you can. 5 minus negative 4 turns into 5 plus 4, which is 9. Right? Minus minus becomes plus. Square root of 9 is 3. Forever and always, if you take the square root of 9, you're going to tell me it's 3. And then, does 3 minus 1 equal negative 4? Absolutely not. It's just not true. That tells us that x equals negative 4 is not a valid solution. It doesn't work in the original equation. So we do not circle it. We do not put it in our solution set. The only solution to this equation is x equals 1.